Good evening. Good evening. Kim. My name is Niles Parker, and it's a pleasure to welcome you to the Collins Center tonight and to the premiere of The Warming Sea. Finally. It's been a long time coming. I'd like to thank Versant Power, our headline sponsor for tonight's event. Thank you for your support. I'd also like to make sure that you saw out in the lobby or on the programs that you may have received the QR code, and please feel free to scan that code. You can use your phone and download an expanded version of the program with more information and links to the Warming Sea website. We hope you will return to it often when you get home after tonight's performance and take time to explore more of the content which is available there. And really importantly, I want to make sure that everyone knows that after the performance, stay in your seats, because we're going to have a talk back here featuring some of the scientists and the people that Lucas interviewed along the way to help inform him in his composition. And I'm really happy to report Lucas himself here tonight. I haven't seen him yet, but we're obviously just thrilled that that's the case. It has been estimated that for most people, 95% of the science they learn or are exposed to happens outside of the traditional classroom. Places like museums and science festivals like this one this week are key players in the dissemination of public science. And since Maine does not have a public science museum, MDM, our board, and our staff made the decision about 8 years ago to step into that space and increasingly develop science programming that appeals to people of all ages. And it was about at that time that Kate Dickerson approached me with her idea for starting the Maine Science Festival, and it just seemed like perfect timing. Hold that thought, please, because I'm going to call out Kate in a second. I learned quickly that Kate had a deep passion for this concept, and that she is a force of nature. All who work with her are energized, and I realized I just had to get out of the way and let her run with it. And while COVID threw a wrench in our plans for the past 2 years, Kate has kept running. The Science Festival has become our biggest program, has a statewide impact of much more than just 5 days in March, and is central to our vision of building more opportunities for all Mainers to engage with science. You'll be hearing a great deal from Kate later on, but I would like to take this time to recognize Kate and thank her for her tireless efforts and for making this event happen tonight. So about 5 years ago, having had the chance to work with Kate by then on the Science Festival, I was especially excited when she pitched an idea for combining art and science in a really unusual and collaborative way. She said, I want to commission Lucas Richmond to compose a piece about climate change and have the Bangor Symphony Orchestra perform it as part of the Maine Bicentennial celebration. And wow, I love the idea. Though admittedly I wasn't sure at first how a symphonic composition was going to explore climate change. But again, I saw Kate's passion in the idea and I knew where this was going, so again, got out of the way. And I knew that collaboration is critical to success. And in terms of solving fundamentally important problems, creative collaboration leads the way. And the chance to collaborate with such wonderfully creative people as Lucas and work closely with Brian Henricks and the BSO was deeply exciting to all of us. And so we were just thrilled when they said yes. And tonight's program is a result of that collaboration, and I'd like to take this time to thank Lucas and Brian and the BSO for taking a gamble on this idea and jumping in on this project so willingly. So thank you. Maine and its many organizations, companies, universities, and researchers as a whole, I think, seem to collaborate really well. It's one of the things that I love about Maine and I think is really unique. And again, it will take such creative collaboration to solve the many challenges our society faces, none of which are more important and urgent than the issue of climate change. And at this time, it is my honor to introduce the person leading our state towards tackling that issue. Elected in 2018 as the first woman governor of Maine, Janet Mills won more votes than any governor in Maine history. Since taking office, she has made reducing carbon emissions, creating good-paying jobs in the clean energy sector, transitioning to renewable energy to combat climate change, and reducing energy costs for Maine people a top priority. She has pledged Maine will be carbon neutral by 2045, and with the bipartisan support of the legislature, the state has enacted among the nation's most ambitious renewable energy and emissions reduction targets for Maine. Governor, I'd like to thank you very much for joining us tonight, for supporting science, and for your leadership in developing Maine's climate plan. And I'd like to welcome Governor Mills to the stage.
It's a delight to be here. And I know you're all familiar with this book that we published at the height of the pandemic, December 2020, my administration, with the help of our Department of the Future, led by Hannah Pingree, a 4-year plan for climate action called Maine Won't Wait. And we are accomplishing these plans as we go, inch by inch, mile by mile, year by year, because we know that for more than 80 years, scientists have been warning us that we are changing our climate. What we're doing as humans is changing the climate. And the scientists worry. That worry has been a drumbeat, data getting louder, and with every extreme storm, every degree change on the thermometer, every ocean wave that creeps further on shore. Scientists are calling climate change a code red for humanity. Their alarm is echoed by a growing chorus, a chorus of farmers whose fields are dry, communities whose streets are underwater, fishermen whose oceans are warming, youth who fear for the world that we are leaving them, and loudest still, the courageous people who are determined to do something about it. People like Sylvia Earle, the deep sea diver and scientist, who warned just this week, quote, "It is high time for the high seas, the blue half of the world, to be recognized as the blue heart of the planet, the cornerstone of Earth's life support system, the vast but vulnerable part of the planet." Tonight, we all add to these voices a symphony of science to inspire action against the threat of climate change. Maine is working hard to bolster the resilience of our communities, to create clean energy, green-collar jobs, to build a clean energy economy, and to support Maine families and their transition away from expensive, harmful fossil fuels and to homegrown renewable energy. No time more critical than the present with what's happening in the world today, but we need the help of everyone here and beyond. It might be easier to put off climate action until calmer times, but Maine can't wait. Maine shouldn't wait, and Maine won't wait. So may tonight's concert move you to not wait, but to take steps in your own lives to help preserve our planet. And for my part, my administration will continue to do all we can against climate change and to protect this place we love and call home, not just the beautiful state of Maine, but this nation and this world, so that generations to come may enjoy it as much as we do in a healthy, happy fashion. Thank you. Welcome.
Hi. Good evening, Maine. It's lovely to be here. Thank you to the Governor for those amazing words. The UK is really, really pleased to be here as the Science Festival's international partner. We're so honoured to be working with the Science Festival. And as COP president, it's really important to us to showcase excellence in climate science, and that is exactly what Maine does. So we're doubly delighted to be here this evening. For those of you who I haven't had the chance to meet, my name is Ronnie. I'm the UK Science Attaché, originally from Melbourne, Australia, but now working as a science diplomat for the UK, where I've been with the Foreign Office for around 7 or 8 years, depending on whether you count COVID years, struggle with that. Anyway, I am really delighted to moderate this panel. I should say that when Kate and I originally spoke about the Science Festival, it was 2020, and Kate said to me that this Science Festival is unique, really, because it is science by Maine, and it is a science festival for Maine, unlike many science festivals where they fly in external speakers and try to kind of galvanize an outside crowd. And I said, well, how do you keep it that way? And she said, it's easy. We just hold it in Bangor in the middle of March, because Maine is the only ones brave enough to tough out the weather. So thank you, Mainers, for coming through the rain to be here tonight with us. And what an honour for me to be on this stage with these 3 climateers. Climateers is what happens when my brain mixes science, climate researchers and planeteers for any Captain Planet fans out there. So what I'm going to do tonight, we've got about 30 minutes on stage together. You guys have a little science, a little symphony. It's like an appetizer course. I'm going to ask them to introduce themselves to you instead of me reading out their very impressive CVs. I did only slightly warn them about this. That I'm going to ask them to introduce themselves in 2 sentences, and then they're going to give you a little bit of a snapshot into the research that they do. But there's a catch. In the 2 sentences, I'm going to give them 2 words they have to use. Don't worry, it's not going to be like kangaroo or anything. So, on the stage we have Kat, Seth, and Cassandra. Welcome. Fair warning, one of the words is about your scientific discipline, and one of them is about your history. So you get to say how you came to science and what you researched. So let's start with Kat. My 2 words for you are seashells, or less romantically known as marine microfossils, and, as is hard for an Australian to say, New Zealand.
Thank you. Well, I love seashells, and I have since I was a little kid, and the passion continues to this day at a very microscopic scale. And my passion for science also took me via New Zealand, where I learned a lot about geology and lots of other things. And lots of life events happened for me there as well. That's where my husband and I got engaged, so it's a special place for me.
Amazing. And I'm Kat from University of Maine. Seth Campbell, your 2 words are glaciers, that one's easy, and beavers.
Okay, I grew up in Maine, and I was introduced to science through my father, who, my mother does not know this, probably still doesn't know this, worked as an environmental science technician, and he had to be crawling underneath rafted ice on lakes to try to find radio collars and slip off of beavers. Probably not the safest location to be growing up, but really exciting for me to come out with mud all over me, finding a beaver collar that he was tracking, looking at the rising and falling of water levels in lake reservoirs that we use for hydropower in Maine. So that's what introduced me to science. And then the second sentence, I guess, or the first sentence. The second sentence is glaciers. I spent roughly 10 years of my life in the last 2 decades on glaciers in Antarctic, Arctic regions, kind of witnessing and studying the changing glacier systems across the planet. That's what brought me to Maine. Maine's a phenomenal place to study climate change from a glacier perspective.
Brilliant. Ron Seth from the University of Maine. Finally, Cassandra, your talk towards our innovation and rocks.
Yes. Thank you, Roni, and hello, everybody. I'm Cassandra Rose from the Governor's Office of Policy, Innovation, and Future. My office is right there, the Governor. And I came from an unconventional background. I was the first in my family to go to college, finish a college degree, and much less go into science, so I was a little bit of an oddball. I wore a dress today that speaks to my great love for things that you find in rocks, fossils, dinosaurs. I also really got into space as a child, which I think a lot of kids love dinosaurs and space. They're sort of the gateway sciences into the geosciences. And so I really I fell in love with rocks. They're kind of windows into the past and understanding how our environment works to better understand how it'll change in the future. So rocks were a great introduction. And of course, I work for the Governor's Office of Policy, Innovation, and Future. I think we're being very, very innovative here in Maine in our approach to climate change, and I'm just really excited to be part of the team here.
Amazing. So ladies and gentlemen, you're going to get 4 minutes on the research of each of these climateers and their research and policy work, I should say. Starting with Kat. So Kat, over to you. Yeah, it's right there.
Great. Well, thank you so much. Today I am going to tell you a little bit about ocean research that is happening at Maine and elsewhere. And as you're probably quite familiar, the planet is warming. And the presence of heat-trapping gases in our atmosphere is leading to a lot of energy building up in the system. Recent studies have shown that 90% of that energy has been taken up by the ocean since 1970. 90% of the heat that has been trapped by these gases has ended up in the ocean. That's a big number, and it's something that we need to keep an eye on. It's a big part of this climate system. I'm an oceanographer who studies both the present and the past ocean. The study of the past ocean is called Paleoceanography, which involves tracking down the histories that are stored in libraries of mud on the seafloor. And I'm going to show you in the next couple of minutes just a snapshot of some work that my group is doing. We work all over the planet, but this summer we were in the Gulf of Maine, and I'm going to show you some images of that. So next slide, please. This is our team. We went in August with a crew of people drawn from the University of Maine, from Oregon State University, from the University of Rhode Island, and from Bigelow Labs. And we were on a mission for mud. We were after understanding what happened in the Gulf of Maine for the past several thousand years. It's important to understand the long-term dynamics, to look at the trends and the variability in this system. And so we went out to go find some ancient records. Next slide, please. And one more. This is the research vessel Endeavour. This is a research vessel operated by the University of Rhode Island. It's approximately 50 meters long and has hosted a ton of exciting science during its several decades of operation. Next slide. This is a multi-core. This is a device that we use to bring up mud from the seafloor. This is very useful for getting mud that is located hundreds of meters, thousands of meters below the seafloor. You can't dive that deeply, so we send devices down to get it for us. And next slide. This is a video from a GoPro strapped to this multi-core device that is heading down to the seafloor and just plunged into the mud. This is the very surface sediment that we were after and we were hoping to collect. And we indeed got it here. It is going to come back up to the surface, and there are going to be some very excited scientists on the other end. Next slide. The fish were quite interested in what we were doing. This is very unusual activity in their backyard. These surface sediments are chock full of exciting things for marine scientists. They contain fossils, they contain living things, they contain clay and dust and clues. All of this mud that just looks like brown, uniform mud from a distance is a rich archive. Next slide. And back one. Thank you. This is one of my graduate students who's working on our team. She's very excited to have pulled up this device containing sediment from the seafloor. We are currently working with this to understand ocean history. Next slide. And click one more time. This is a drone image of our research vessel Endeavour preparing to take a long core. So to go thousands of years back in time, it requires a lot of longer of a coring device. And so with this, we, off the A-frame of this vessel, off the back of this vessel, we are preparing to drop a long tube with a big heavy weight on it to collect material that has been building up slowly on the seafloor, witnessing changes that I certainly wasn't around to see myself for thousands of years. Next slide. This might be my favorite. This is a GoPro capturing the long core. And we had a local come check us out. This is a blue shark who's very interested in what the heck we were doing out there. These long gravity cores bring back several meters worth of sediment, which can contain microfossils and valuable pieces of information that allow us to put together the Earth climate behavior over a period we call the Holocene. Next slide. Here is another very excited graduate student whose thesis has just come up from the seafloor. And we are currently working to pull these fossils out of this mud. Next slide. Here we are with our loot pulled up from with all these coring devices in a Maine van that was just under the weight limit. Next slide. And then we went to the Paleoceanographic Institution where we sliced all these cores open and were able to take samples back and work with them. Next slide. Here is Lexi Thompson, one of our very own undergraduate students at the University of Maine. She's doing a senior research thesis with my research team, and she is currently slicing a core open with what's basically a giant cheese cutter. Next slide. Here we are working with those cores that have just been sliced in half, and we are taking our very first observations and making decisions about where we want to sample and figuring out which pieces of the fossil record we're going to focus on. Next slide. And here we are, the grand finale, a piece of history that is smaller than the size of a grain of sand. This is a microfossil. It is a type of foraminifera. Its name is Neogloboprogena incompta, and it holds a key to the past. It holds a key to the past because the chemical composition of that shell, which is basically made of the same stuff as a shell you might pick up on the beach, but there are little tiny clues within the shell that can allow us to reconstruct what past ocean temperatures were thousands of years ago. And that's what we're doing here at the University of Maine. Next slide. So with that, I want to thank a lot of people shown here, in particular my family, my husband and my daughter did great while I was at sea. They actually had a wonderful time, and she climbed her first mountain under her own steam. And I want to thank the wonderful colleagues and collaborators and sources of funding that made this all possible. Thank you.
Thank you so much, Kat. That was brilliant. I told Kat I should have named the talk what I did last summer. But I think that Mother didn't have graduate students, so it was just amazing. And over to you, Zach.
Thank you. Oops. Of course. All right. So, I was asked to be here, I think probably because what happens in Maine doesn't necessarily originate for me. A lot of the work that I do is global. And that's the main take-home point that I want to talk about tonight, that we have to start thinking more globally and start collaborating with people across borders and across communities and across political affiliations. And I thought I'd use a couple of examples here to show what I'm talking about. So the first slide I showed here is actually from the geoice field in southeast Alaska. Maine's very fortunate that we were able to bring the Joint Field Research Program, which is a program that's been operating since 1946, to Maine as an academic program. The interesting thing about the ice field is that we have scientists, educators, and students from undergraduate through college through graduate programs combining forces, joining us on the ice field together to do research together. These students and these scientists come from academic institutions around the globe. It's one of a kind program, which is really unique, and I think it sets a good example of that. Next slide, please. So, why is that important? Well, I figured I'd show a few slides about the changes we're seeing and how that ultimately, I'll talk a little bit about how that ultimately is impacting Maine. So this is a model that shows basically a combination of all temperature data that's been taken across the globe from the late 1880s until now. And what you'll see is any place that's red is gaining temperature, it's warming up. And any place that's blue is losing atmospheric temperature. So this data was compiled by folks at NASA. And you'll notice that the Arctic regions are much redder than other areas. And you'll also notice there's this little peninsula in the bottom left-hand side of Antarctica also warms up significantly. Right? So that change in atmospheric temperature, we call it Arctic amplification for the Arctic region, is really significant and impactful for us in the state of Maine because it alters things like ocean warming, ocean circulation processes, atmospheric circulation processes that we need to account for. Next slide, please. So as a result of that Arctic amplification, this is a simple schematic that shows the amount of glacier change that's occurred across regions across the world. So the size of the circle, the size of each circle, denotes the amount of glacier change over the period of time from 1961 until 2016. And you'll notice Arctic Canada, the upper left-hand side, and Alaska account for a significant portion of that change. And it's because it's in that region of most significant warming, and a lot of the ice, it's a rate of about 0 degrees, so basically right at the melting point. So if you increase the atmospheric air just minimally, you have a huge change in ice mass that gets dumped into the ocean. And that water being dumped in the ocean has multiple impacts. One big impact is that it influences the ocean circulation process. It also impacts microbiology that Kat was talking about earlier, and macrobiology, larger species that feed off of that microbiology. Next slide, please. This is a model from Greenland. I think that's it's from. This is a model from Greenland from NASA as well that shows glacier change across Greenland. So same thing applies. Anything that red is losing greater amount of ice mass. Anything that's less red is losing less mass. And you notice most of the periphery of Greenland is losing ice mass, a significant amount of ice mass. This timeline runs from 2002 to 2020. So again, this meltwater, this ice that's melting, it's dumping off of Greenland, and it's basically working its way south, and it's influencing the coastal circulation process that we have occurring in Maine. That's why Arctic processes, global processes are important. And the next slide. The last slide that I figure I would end on is looking at Antarctica. And I think this is great that Ronnie's here because she represents the UK as well. You'll see this region that's reddening in West Antarctica, that's where Thwaites Glacier is located. And you have this major international cooperation between the United States and the United Kingdom where we're studying this glacier system because West Antarctica represents the potential for 3 meters of potential sea level rise. That's a huge amount of sea level rise, right? Portland would effectively be underwater. So what I do, what a lot of scientists do at Maine, we basically working to bring that research back to Maine and figure out how that might impact Maine. Okay. Thank you.
I have to say, when we were invited to this panel, I didn't know I would have a really example of UK-US collaboration with me on stage. So here's what we prepared earlier. And now, if you, Sandra.
Well, I'm going to take a slightly different approach and tell you about research that I used to do before the last 6 years of work in science communication and science policy. And I would like to thank Kat, who I actually went to graduate school with. We were in the same program, for doing such a great job of introducing ocean sediment cores, who all will have a great understanding now when I talk a little bit about them. So as I mentioned earlier, I was the first in my family to go finish a college degree and then first scientist. And I really was excited about the concept of change over time, evolution, and also how our climate has changed through history. And so I went from banging on rocks with my trusty rock hammer, which I still use to break up ice in the winter today here in Maine, into graduate work that had me trying to understand how long-term shifts in hydrology changed in North America and Africa. I studied the hydrological and vegetation evolution of Northern Africa over the last 25 million years during my PhD. And I did that by trying to look at ocean sediment cores from around the edges of Africa, which have more complete environmental histories. And I tried to look at molecular fossils. So these are compounds that originally came from plants on land. And by reconstructing their isotopic composition, the elements that are within them, we can have an understanding of how rainfall and vegetation have changed over millions of years. Africa is a great place to look at both long-term changes and how shorter-term climate variability changes over time, because the signals are very, very big. They're hard to miss in ocean sediment cores. So I spent 5 years basically taking samples of mud from sediment cores around the margin of Africa, throwing a lot of chemicals at them, extracting different compounds. The picture on the lower right shows different shades of green, or different amounts of compounds I was trying to analyze, and then throwing them through something called a mass spectrometer to look at their elemental composition. And that was great. I gained a really wonderful, comprehensive understanding of how our climate has changed and why over the last 25 million years on the planet. Next slide, please. And so several years ago, I finished with a PhD. But one thing that I discovered by studying the climate history of our Earth is that what's happening right now is unprecedented, perhaps unprecedented in Earth history. So this graph here just shows you how carbon dioxide, which is a major greenhouse gas in our atmosphere, has changed over the last 800,000 years. And if you go from left to right, you can see it goes up, then it goes down, and actually global temperatures mirror these shifts over time. So we're seeing global climate go from warmer to colder over time. But when you look towards the present, all the way to the right, we can see that something different's been happening for the last 150 years. And so I put a couple of bars over the right to show you that the natural range of CO2 has generally stayed between 180 and 300 or 280 parts per million over the last 800,000 years at least. But since the late 1800s, the CO2 concentrations in our atmosphere have been rocketing skywards. If we look at the last 80 years in particular, we can see that in 1960, we were up around 320 parts per million. By 1980, we were almost at 350. By 2000, it inched higher. And there's a little bit of a trend here. We can see that CO2 is going up ever more quickly at faster rates through time. So in terms of geologic time on Earth, it's going up super fast. So I getting the signal from Ronnie to move forward. Next slide, please. So I shifted from academic research into working in science-informed policy making over the last 6 years of my career, and I've been very lucky to land in the great state of Maine, working to support a group called the Maine Climate Council. It's a group of over 300 volunteers with expertise in science. We have bipartisan state and local government officials, as well as representatives from all walks of energy, community resilience, public health, and other sectors. And so we shifted from working just before the pandemic all the way through the pandemic on our state climate action plan. Next slide, please. And that climate plan, which Governor Mills gave a fantastic introduction to, is called Maine Won't Wait. It is working to lay out a plan for the state to address our greenhouse gas emissions, to lower those over time, to avoid the costs and impacts of inaction, and to prepare for the impacts of climate change. to foster economic prosperity with our climate transition and to do so in as equitable a way as possible. Next slide, please. So I've run out of time. I know we need to move on, but I want to encourage everybody to visit a new website that we've put together, mainewon'twait.org, which describes the climate plan and also has fantastic videos and stories of action that Mainers are taking today all across our state in support of the goals of Maine Won't Wait and to really tackle this growing climate crisis. So I'm going to leave it there and thank you for your attention.
Thank you for your work. I have to say, it's so hard to stop these presentations. You can see me being like, I need to stop, but I don't want to stop. I don't want to hear more about this. So I did just want to take a few minutes to ask these people some questions in a cabinet too, because I know we're all waiting for the main event. But Cassandra just mentioned Maine Won't Wait. And as I said, the UK is really pleased to be working with the great state of Maine and to have signed a memorandum of understanding just last year on how we increase that collaboration. So Cassandra spoke a bit about what the public does to sort of get involved in Maine Won't Wait. And I want to ask our researchers here. I mean, in a way, research is a public endeavor, right? All of these taxpayers are your bosses, effectively, because they pay taxes and in a way that funds research. So my question for you guys is, how does the public shape the way that you think about your research or your job as a scientist? Start with you, Kat.
Sure. Well, I think that the dialogue and participation is really important, and it's something that has become harder during COVID, but it's made us value it more, and so we have to work a bit harder at sharing our work and at getting feedback and getting community involvement. And so my work personally, I think one thing that we're working to do is to work with local educators, and we're also teaming up on a citizen science initiative that some of my colleagues at Maine have been running for several years already, and so combining citizen science and using their feedback, coastal erosion monitoring, and then also trying to connect with the local teachers and also learning about what they need and what they want and what their learning goals are and how we can help, really. So that has been, as I said, more challenging recently, but if there are any middle and high school educators out there, please reach out if any of this sounds interesting to you. And we are currently working on things like virtual field trips and really wanting teacher feedback on how this work might connect with or excite your students. So that's one way.
That's brilliant. Everyone, if you want to be a citizen scientist, Kat's lab is recruiting people now. Separately.
I would say the same thing, actually. To me, it's about education. And actually, I'm going to point someone out. Where's my niece? Hey! Awesome. So last year, I got to do a fun little event with my niece. She's at her school. And this year, we received a significant grant from the National Science Foundation to work with a group of schools across the country. And it's focused on building leaders in their own communities. The future leaders, the future science leaders, the future voices. I mentioned the GeoISO research program earlier. We really need dozens of those. We need hundreds of those. We really need an army to make some forward progress. So, a lot of the science that you've heard us talk about today, it's clear, it's obvious. Yes, we can always keep tweaking models and keep learning more, but it's at the point where we need engagement with you all to make forward progress. And I think that really does start with the next generation too. So the more education programs we can have that focus on Earth system science processes and how global processes impact us here at Maine, I think we're going to be better off in the future.
You've heard that. This is actually a recruitment fair, so I hope you're all ready to sign up. All right, I have one final question for our three climateers, and that is a little bit of a tough one, going into what I think is a emotional process for a lot of us, and that is people talk about being a climate optimist or a climate pessimist. I'm not going to ask you which one you are, but in the sort of, to use the phraseology of Lucy's piece, how do you, in your work, confronting this every day, how do you balance truth and hope? I'm going to start with you, Cassandra.
Easy question, I guess you wanted to start, end off with. I think working as a scientist, working with science, I really try to ground the work that I do every day in being guided by what data and our best understanding of the science of climate change is telling us. And I think it's telling us that certainly there's not a lot of time left to take action to keep our future warming to minimal levels, but it is saying there is still time. And a lot of great effort and research has gone into laying out the options that we can take to move forward, to keep our planet as habitable as possible, and to keep our communities and ecosystems as safe as they can be. And so I'm really inspired by the fact that here in the state of Maine, we are being guided by the best science and working towards those goals that we know are going to keep warming to as minimal an amount as possible. And I find that very hopeful. I also find it very hopeful that there has just been an enormous sense of rolling up our sleeves and getting straight to work here. Everybody I work with, everybody I talk to just wants to know what they can do, and I think that is very inspiring, especially as a climate scientist, so I'm really thrilled to be doing this work here.
Thank you. Seth, what about you? How do you balance?
Yeah, I think watching the news nowadays can be demoralizing for a lot of us. I know it is for me sometimes. I know I personally have a tendency to unplug from the news when I'm getting down, and then I look at some science, and I work with my students. The students that I work with at Maine are incredible. I have a few students that send me daily pictures of what they're working on. It's always something amazing. To me, that's the hope side of things, right? So I keep that in mind as we're working with some pretty challenging environmental issues that we're facing. I really think it goes back to the students and kind of the up-and-coming generation.
Amazing. You've had my time, as I said, we've been here for exactly 30 minutes. So Kat, it's over to you to give us the last few thoughts on hope and truth.
The facts are deeply concerning, and yet there is reason for hope. We have the capacity to make major changes and to make them rapidly. And it's been shown in the past that leaders can listen to scientists, and as a global community, we can make changes. Look at what we did with the ozone layer, and the chemicals that were destroying that. There was a very rapid global movement. Also helped that it was also financially beneficial to switch to those other chemicals. But the president of the United States in World War II listened to the advice of an oceanographer about, no, wait one more day, don't send the troops to the beaches because the tide is wrong. And there are, if leadership listens to science, and if communities band together and make a decision to do something, we have done these things before. We have made the right decisions before. We can do it. We just have to have the willpower. We have all the tools. We have all the knowledge. We know what the problem is. We can do it if we just find the will.
Could not end on wise words.